Alright guys, remember our rule for multiplying with exponents. So go back and look at our foldable here. Multiplying with exponents that have the same base. So if I have a to the m times a to the n, what did we do to those two exponents? Well, you're simply just adding them up if you have the same base here. So let's start with question 1. N squared times n squared. We have the same base. So use our rule. We're just going to take our exponents and add them. So 2 plus 2, that would be n to the 4th. Don't forget about the last n. Now if you don't see the exponent there, there's a 1. There's a little hidden 1. And go back to our rule again. We have the same base here, n and n. So 4 plus 1, we're adding the exponents. That would be n to the 5th power. Let's look at question 2. Start with your numbers. We're multiplying 5a to the 5th times 6a to the 6th. Start with your numbers. 5 times 6. 5 times 6 is 30. And then let's look at our a, our letter a here. A to the 5th. So we have a to the 5th times a to the 6th. A to the 6th. Remember our rule, we're just adding the exponents. That would be a to the 11th. And we are done. Don't overthink this. This is really simple if you just remember your little shortcuts or our rules of the laws to the exponents here. Look at 3. Let's start here with our y's. Y to the 3rd times y to the 2nd. Now if you have to write this out off to the side, y to the 3rd times y to the 2nd. Remember, we're adding the exponents because we have the same base value of y. That would be y to the 5th. So we're done with the y's. Now let's look at the letter z. Remember what we said, if there's not an exponent, there's a little hidden 1. Z to the 1, z to the 1st power, times z to the 3rd power. We're going to use our rule. 1 plus 3 would make that z to the 4th power. And we're done. Pretty easy, isn't it? Number 4, start with your numbers here. 5 times negative 2. 5 times negative 2 is negative 10. We're done with the numbers. Let's jump over to the letter y. Y to the 3rd times y to the 4th. And remember our rule, 3 plus 4 would make that y to the 7th. And we're done. Try number 5 by yourself here. I'll give you about a 15-20 second head start and then I'll see where you're at. Give you a hint. Start with your numbers, then go to your letter y, then go to your letter z. Alright, start with our numbers. 3 times 4, that's going to give me 12. Jump over to the letter y, y to the 3rd, times y to the 4th. We're multiplying with the same base, so that's going to be y to the 7th. And our final letter, z to the 1st power, and z to the 2nd power. So z to the 1st power times z to the 2nd power. We're just going to add those exponents. 1 plus 2 would make that z to the 3rd power. Alright, number 6, I'm going to put a negative 1 there. Remember, there's a hidden negative 1, there's a negative 3, and then there's another hidden negative 1. So we're going to just multiply 2 of these, and then at the very end we'll finish up with that last term. So let's start with these 2 guys right here. We're going to multiply these first. So let's start with our number, negative 1 times negative 3. Negative 1 times negative 3, that's going to give me positive 3. Now let's look at the r's. R to the 2nd times r to the 1st. Remember our rule, we're just adding 2 plus 1, that'll make it r to the 3rd. Jump over to the s, s to the 1st power and s to the 3rd power. So s to the 1st times s to the 3rd. Remember our rule, that would make that s to the 4th. But we're not done. Now we have to take this answer here and multiply it times this last term that we still have left over. So we're going to bring that guy down here. negative 1s squared. Again, we're just going to repeat our process. Start with your numbers first. 3 times negative 1. 3 times negative 1 is negative 3. Then we'll jump over to the r's. Well, if you don't have any r's to multiply, you just simply bring it down. R to the third. And then our last letter is s to the fourth times s to the second. S to the fourth times s to the second. We add those exponents and we get s to the sixth. Voila. Looks very complicated, but you just got to keep following your steps and remember your little exponential rules here. Oh boy, we see a fraction, we flip out because we just hate fractions, but we're going to do this problem in two parts. We're going to look at the top part and then we will evaluate the bottom part. So all I want to do is look at this top part right here. And we're going to multiply, because that's what the little dot here insinuates. We're going to multiply just the numerator here at the top. So start with your numbers. 4 times 21. That is 84. All right, we're done with the numbers. Let's look at the letters. H to the third times h to the first. So you have h to the third times h to the first. You add the exponents because we have the same base. That would be h to the fourth. Now we're going to jump over to k squared, or k to the second, times k, right here, k to the fifth. Add the exponents. That would be k to the seventh. We are done with the top part. Now we are going to evaluate the bottom part. We're going to multiply these two guys right here. 7 times 2 is 14. And remember, if you have a fraction, think, can you reduce that fraction? Can we reduce 84 over 14? If you're struggling with the reduction piece, take your calculator out. And let's type in 84 divided by 14. And let's see if the calculator will give us a reduced value here. In fact, they tell you that 14 goes into 84 6 times. So that means that we will be left with 6 h to the fourth, k to the seventh. Let's skip down to number 9. Number 9, you have multiplication on the left, multiplication on the right, and you have addition in the middle. So you got to go back to grade school, go back to 6th and 7th grade and think about, what do you do first? Do you add first or do you multiply first? Well, we have to multiply over here on the left first, then we have to multiply on the right first, and you always add or subtract at the very end. So let's start on the left here. Let's start with our numbers. 2 times 4, that gives me 8. And so you guys are getting good enough now, I hope, to where I don't have to write out the letters here. Y to the first times y to the third. We're just adding those exponents. 1 plus 3, that would be y to the fourth. Now we need to come over here to the right side. And let's multiply the numbers here. 3 times 5, that is 15. And let's look at our letters. Y to the second times y to the second. Since we have the same bases, you're just going to go 2 plus 2. That would be y to the fourth. And then look at our symbol in the middle. It's asking you to add these if you can. Remember, go back to the first semester of Algebra 1, combining like terms. You can only add or subtract or combine y to the 4s with y to the 4s. And guess what? I have y to the 4s. I have 8 of them on the left and 15 y to the 4s on the right. So I can actually combine those like terms. So then you do 8 plus 15 and you get 23 y to the 4s. Or 23y to the fourth. Okay, what I want you guys to do is I want you to pause the video and try to do question number 10 just like we did question number 9. Start over here on the left and multiply those two guys together. Then come over here to the right, multiply those two guys together. And then at the very end, bring down your subtraction sign and see whether or not you have like terms. Start on the left here. 6 times 2, that gives me 12. And then s to the second times s to the second. We just add the exponents. That's going to give me s to the fourth. Let's look over here on the right. Start with your numbers. 3 times 4 is 12. Then let's look here, s to the 4th times s to the 3rd. 4 plus 3 is going to give me s to the 7th. Bring down your subtract sign. So the question is, can I subtract s to the 4th with s to the 7th? No, they have to be the same term. S to the 4s can only be subtracted with s to the 4s. I cannot combine these. These are two different terms. And so my answer cannot be simplified. In fact, our answer is what we're left with here, 12s to the 4th minus 12s to the 7th. Do you remember what 11 kind of looks like when we did something like this here, and then we did something like this here, and we have the third one? Remember what that's called? The distribution property. That's exactly what we're going to do. And remember, when you distribute, you are multiplying. So we're going to apply our same rule with exponents here when we multiply. So let's start with this 7ab and 2a. We're going to pretend like we're going to multiply those like this. So you could pretend like that can be written like this if you wanted to. So start with your numbers. 7 times 2, or if you want to look over here, 7 times 2 or 7 times 2, that would be 14. Now let's look at the a's. A to the 1st times a to the 1st, or if you look over here, a to the 1st times a to the 1st, that's a to the 2nd. And we had a problem previously that if you only have the letter, you just simply put that letter in the problem if you don't have anything to multiply with. So we're done with this first distribution. Now let's look at the second distribution we have. 7ab times positive 4b. So we have 7ab times positive 4b. So here we go. But whenever we get our answer from what we wrote in purple here, we need to start writing that over here with the term that we already have from the first distribution. Start with your numbers. 7 times 4, that's positive 28. So we're going to put plus 28. A, I don't have any a's to multiply, so I'm simply going to put the letter A in the problem. And b to the 1st times b to the 1st, that would be b to the 2nd. Now you don't have to write this out over here. You could simply go 7 times 4 is 28. There aren't any a's, so I bring it down. And b to the 1st times b to the 1st is b to the 2nd. If you're good enough to do that, you can skip this process. But I want to show you an alternative way of just simply rewriting the distribution process here. And our last one, 7ab times, this is negative 6. So we're going to put negative 6 in parentheses right here. So start with your numbers. 7 times negative 6, that's negative 42. And we don't have any letters to multiply. We don't have any a's and b's from the negative 6, so we're simply going to put that in the term with 42 and see if we can combine like terms. You can only combine a squared b's with a squared b's. I don't have any more a squared b's. I only have this set right here. You can only combine ab squareds with ab squareds. And I only have this set of ab squareds. And ABs can only be combined with ABs. So guess what? This is my answer. Number 12. Give number 12 a shot. Start with your first distribution here. Negative 7mr times 12m. If you need to write that off to the side, to help you out, you can. Start with your numbers. Negative 7, positive 12, that's going to give me negative 84. Let's jump over to the m to the 1st times m to the 1st, that's going to give me m to the 2nd. And since we don't have any r's to multiply, we're just simply going to put the letter r at the end. So we're done with our first distribution. Let's start with our second one. Negative 7mr times negative 7r. So let's write that over here. Negative 7mr times negative 7r. Start with your numbers. Negative 7 times negative 7, that is positive 49. Since we don't have any m's to multiply, we're just simply going to put the letter m there. And then let's look at our r. r to the first times r to the first, that is r to the second. And now our last distribution, negative 7mr times positive 5. Negative 7mr times positive 5. Start with your numbers. Negative 7 times 5, that is negative 35. And since we don't have any of the m and the r's to multiply, we simply just put them at the end. See if we can combine like terms. M squared r's can only be combined with m squared r's. Do I have any m squared r's? No, these are the only m squared r's I have. This is not m squared r. This is mr squared. Mr squareds can only go with mr squareds. And mr, Mr, can only go with Mr. So guess what? This is our answer.